Some of you might not quite be finished yet, but that's okay. Let's go ahead and take a look and see how these are going for you. So for number one here, this one I'm going to go ahead and use the Cramer's rule on it. My base matrix, 3, 1, negative 1, 2, giving me a determinant of 6 minus a negative 1, or 7. My X matrix is 8, 19, negative 1, 2, giving me a determinant of 16 minus a negative 19, or 35. And my Y matrix is 3, 1, 8, 19, giving me a determinant of 57 minus 8, or 49. So X is 35 over 7, which is 5. And Y is 49 over 7, which is 7. So the solution here, X is 5 when Y is 7. Second equation over here, we're going to go ahead and do Cramer's rule again. Our base matrix, 2, 4, 3, negative 3, 1, 2, 2, negative 2, 1. And we'll recopy those columns. Going down, 2 times 1 is just 2. 3 times negative, or negative 3 times negative 2 is positive 6. Sorry, times 3 is 18. 2 times 4 is 8, times 2 is 16. That gives me 36 going down. Going up, 3 times 1 times 2 is 6. 2 times negative 2 is negative 4, times 2 is negative 8. And 1 times 4 is 4, times negative 3 is a negative 12, which gives me a negative 14. 36 minus a negative 14 is a 50. Is my base matrix determinant. My X matrix, 3, 9, 18 goes in place of the X coefficients. The Y's and Z's are still there. We rewrite those first two columns, and we'll go down. 3 times 1 times 1, 3. Negative 3 times negative 2 is 6, times 18 is, what is that, 108? 2 times 9 is 18, times 2 is 36, which is, what is that, 147, I believe. My down total. Going up, 18 times 1 times 2 is 36. 2 times negative 2 is negative 4, times 3 is negative 12. 1 times 9 times negative 3 is negative 27, which is a negative 3. So we have 147 minus a negative 3, which is 150. The Y matrix. I have 2, 4, 3. My X's are back. My constants go in for Y. And my Z's are still there. Rewrite those first two columns. Going down, 2 times 9 times 1 is 18. 2 times negative 3 is negative 6. Times 3 is a negative 18. 2 times 4 is 8. Times 18 is 144. For a down total of 144. Going up, 3 times 9 is 27. Times 2 is 54. 18 times negative 2 is negative 36. Times 2 is a negative 72. And 1 times 4 times 3 is 12. Give me a total of -6 on my ups. So 144 minus a -6 is 150 again. My Z matrix. X's, my Y's are back, -3, 1, 2. And my Z's get replaced with the constants. Rewrite those first two rows. Down diagonal, 2 times 1 times 18 is 36. -3 times 9 is -27, times 3 is a -81. 3 times 4 is 12, times 2 is 24. What is that, -21 it looks like? Going up. 3 times 1 times 3 is 9, plus 2 times 9 times 2 is 36. 18 times 4 is 72. Times a -3 is a -216. So -171. So we got a determinant of -21 minus -171, which is 150. So here x is 150. The x matrix was on determinant of 150 over the base matrix determinant of 50 is 3. The y matrix had a determinant of 150 over the base matrix determinant of 50. So y is 3. And the z matrix had a determinant of 150 over the base matrix determinant of 50. Z is 3. So for this problem, x is 3 when y is 3 and z is 3. Any questions on those? Okay. So that wraps up our study of systems of equations. Today we're going to shift gears a little bit, and we're going to look at formulas. So one of the ways we solved these systems of equations was to graph if we had two variables. If we're looking at a graph and we have 2 points, one formula that we've already looked at is the slope formula. So let's say these points have coordinates of 2, 11, and 8. Oh, let's go 8, 7. To find the slope, remember, we used m as our abbreviation for slope. The rise was the difference in the y coordinates. So it was y2 minus y1 over the difference in our x coordinates, x2 minus x1. So that was the x difference was our run. So let's look at how we get those points out of this. First, here's our line. Now, just by sketching our line on our graph like that, we can see that this has to have a negative slope. So if we look at, well, let's label the points 1 and 2. y2 is 0.2, the y coordinate, which is 7, minus y1 is 0.1, the y coordinate, which is 11. x2, 0.2, the x coordinate, which is 8, minus x1, 0.1, the x coordinate, is the 2. We subtract those, 7 minus 11 is -4. 8 minus 2 is 6. Now we reduce this if we can, but remember the one thing we do not do is we do not change it into an improper fraction. Both 4 and 6 are divided by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. Well, you might be thinking, well, what about the negative? We move the negative out in front. It's a -2/3 is that slope. Now, we've seen that formula before. And we've seen that we don't need the graph to use it. we might have a -7, 3, and 5, -1. All we have to do, label our points 1 and 2. Our slope, again, remember M is our abbreviation for slope, is y2, so that's 0.2, the y-coordinate, which is -1, minus y1, which is 0.1, the y-coordinate, which is 3, over x2, so 0.2, the x-coordinate is 5, minus x1, 0.1, the x-coordinate is a -7. So we subtract your -1 minus 3, think of it as a -1 plus a -3, is -4. 5 minus a -7, we think of that as 5 plus a +7, is 12. Both, again, we're going to ignore the negative. We're just going to move that out in front of our answer here. But both 4 and 12 can be divided by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So that slope is a -1/3. In your notes, I want you to do the point -5, 7, 1, -2. I'll give you a minute to find that slope, then we'll go over it. So M equals, again, I'm going to label them points 1 and 2. Y2 is 0.2 y-coordinate, so that'd be -2, minus y1, 0.1, the y-coordinate is 7. X2 would be 0.2, the x-coordinate is 1, minus x1, 0.1, the x-coordinate is -5. So -2 minus 7, I'm going to think of that as -2 plus a -7 is a -9. Over 1 minus a -5, I think that again is plus a positive, which is 6. Now once again, I'm going to put the negative out front. Both the 9 and 6 can divide by 3. 9 divided by 3 is 3, 6 divided by 3 is 2. And I leave it like that. Remember, I do not change it into a mixed number because it is a slope. It's a rise over a run. I have to keep it as those two numbers. I cannot convert it into a mixed number. Then it's no longer in the form of a slope. Well, the next formula we want to look at is for the midpoint. So let's say I have 211 here for points again, and this is 8. And we'll go 8,3, we'll call it. If I want to find the point that's exactly between those 2 points, what I'm really finding is the midpoint of the segment that has endpoints on those 2 points. I can find that midpoint by sketching this out as a triangle, using like my slope triangle basically, my rise and run. That midpoint is going to have an x coordinate that's in the middle of this bottom. In other words, it's halfway between the x coordinate of 2 and the x coordinate of 8. How do I find that halfway in between? Well, I average them together. I add them together and I divide by 2. 2 plus 8 is 10, divided by 2 is 5. 5 is the x coordinate of that midpoint. For the y, it's the similar thing. I have a y coordinate here of 3 and one here of 11. This is going to be in the middle of that. So the middle of 3 and 11, I add them together and divide by 2. 3 plus 11 is 14, divided by 2 gives me 7. So the y coordinate of that midpoint is 7. So the midpoint here is 5, 7. The formula for the midpoint is simply x1 plus x2 over 2 is the x coordinate, and y1 plus y2 over 2 is the y coordinate. The midpoint is one of the few formulas that's going to give us two separate numbers because we have to have a number for each coordinate, for the x coordinate and the y coordinate. So it's actually two separate formulas, one for each coordinate. So if I have the point -3, 9, and 5, -1, I can find the midpoint for the x coordinate by adding together. Remember, it's x1 plus x2 over 2. So I'm going to have x1 is -3 plus x2 is the 5 over 2. Well, -3 plus 5 is just 2. 2 over 2 is 1. So 1 is the x coordinate. For the y coordinate, remember it's y1 plus y2 over 2. We're averaging the y coordinates. So y1 is 9 plus y2 is -1 over 2. Well, 9 plus -1 is 8. 8 divided by 2 is 4. So the y coordinate is 4. So the midpoint here is 1, 4. I'm going to have you try this one in your notes. Find the midpoint between those 2 points. We'll go over it in just a minute. Let's take a look at how you're doing here. So for the x-coordinate, we've got -3 and 7. So -3 plus 7 over 2. -3 plus 7 is 4. 4 over 2 is 2. That's our x-coordinate. For the y-coordinate, we got 2 and 14. So 2 plus 14 over 2. 2 plus 14 is 16. 16 over 2 is 8. So the y-coordinate is 8, so we've got 2, 8 is our midpoint. Now we're not done yet there with our midpoint formula. We might be given one endpoint and a midpoint. Now, to make this easier, rather than having to write out those words every time, our endpoints are going to be labeled points A or B. The midpoint is going to be labeled point M. So if I tell you point A is 3, -5, and point M, the midpoint, is at 1, 1. How can we find point B? Well, we use that midpoint formula. I'm going to label point B for now just x and y. I know that to find the coordinate of the midpoint for x, I take the two x coordinates, 3 and x in this case, I add them together and divide by 2. So 3 plus x divided by 2 equals the x coordinate of the midpoint, which is 1. So now I have created a coordinate here, or an equation here, that I can solve to get that x coordinate. So to solve this, I'm going to multiply by 2. 3 plus x equals 2. And then I'm going to subtract 3. X equals -1. And I can do the same for my y coordinates. I have -5 and y are my y coordinates of the endpoints. So I know -5 plus y divided by 2 equals the y coordinate of the midpoint is just 1. Again. And I can solve that. I can multiply by 2. Gives me -5 plus y equals 1 times 2 is 2. And I'm going to solve that by adding 5 to get rid of the -5. Gives me y equals 7. So this other endpoint B is x equals -1 and y equals 7. So if I tell you that x is 7, -2, and the midpoint is 11, 1, and we're asked to find B. Now again, I'm going to just put in temporary points, coordinates, x and y for that point B, so I can use them in my formula. So I know to find the midpoint for x, I'm going to do 7 plus x divided by 2. That's going to equal the x coordinate of the midpoint, which is 11. Now I'm going to solve that by multiplying by 2. So on the left side, the 2 is gone. 7 plus x equals 11 times 2 is 22. And then we'll subtract 7, giving us x equals 15. For the y coordinate, we know that it comes from adding the two y coordinates and dividing by 2. So we've got -2 and y, so -2 plus y divided by 2 equals the y coordinate of the midpoint, which is 1. So I'm going to solve that by multiplying by 2. So negative 2 plus y equals 1 times 2 is 2. And I'm going to add 2 to both sides. Y equals 4. So that gives me the coordinate here for b. For b, x equals 15 and y equals 4. Let's do one more example of that before I have you try one on your own. So I'm going to ask you to find point A when I know the midpoint is 3, negative 5. And B is negative 2, 1. So, again, I'm going to put in a temporary point, x and y, for A, temporary coordinates. I know that for the x coordinate, I add the two x coordinates. I have x and negative 2. X plus negative 2 divided by 2 equals the x coordinate of the midpoint, which is 3. So I'm going to solve by multiplying by 2. X plus 2 equals 3 times 2 is 6. And then, oops, that's plus a negative 2. X plus a negative 2 equals 6. Then I'm going to add 2. X equals 8. Then I'll do the same thing or similar thing for y. I have y plus 1 divided by 2 has to equal the y coordinate of the midpoint, which is negative 5. Multiply by negative 2 to get rid of the 2. Or sorry, by positive 2 to get rid of the 2. Gives me y plus 1 equals 5 times, negative 5 times 2 is a negative 10. And then it's a positive 1, so we subtract 1. Get y equals a negative 11. So my point A is x equals 8, y equals negative 11. Any questions on that process? Let's have you try one in your notes. So A equals negative 3, 7. Our midpoint equals 2, 1. Find point B. I'll give you a minute to work that out. Okay, so for this one, I'll put in a temporary coordinates, x and y for B. I know to find my x-coordinate of the midpoint, I take my two x-coordinates, in this case negative 3 and x. I add them together and divide by 2. So negative 3 plus x divided by 2 gives me the x-coordinate of my midpoint, which is 2. And I'll solve that. I multiply by 2. Negative 3 plus x equals 2 times 2 is 4. And I'll add 3 to get rid of the negative 3. X equals 7. For y, I have y coordinates of 7 and x. I add them together, or sorry, 7 and y, I should say. I add them together, 7 plus y, and I divide by 2 to give myself the y coordinate of the midpoint, which is 1. So 7 plus y over 2 equals 1. I solve that by multiplying by 2 first to get 7 plus y equals 1 times 2 is 2. And I'll finish solving that by subtracting 7 to get y equals negative 5. So point B is x equals positive 7, y equals negative 5. Any questions there? Our final formula is going to look at finding how far it is between 2 points. So the distance between 2 points, or you can look at it as the length of the segment with endpoints at those 2 points. It's the same meaning. Remember, the distance moved from one point to the next is the same as the length of the segment formed by those 2 endpoints. And again, we're going to go back to that slope triangle, the rise and the run. This is just our rise, and remember that's the difference in our y coordinates. y2 minus y1. This is just our run, the difference in the x coordinates, x2 minus x1. And if you remember, when we have a right triangle, our legs, which would be the rise and run in this case, are labeled A and B, and our hypotenuse is C, and the Pythagorean theorem just tells us that a squared plus b squared equals c squared, or c squared equals a squared plus b squared. Well, we're going to rewrite that formula just a little bit. We're going to write it like this. C is equal to the square root of a squared plus b squared, because we're going to have to take the square root of c at some point anyway to get c, or c squared to get it down to c anyway. We'll put the square root on the other side. So our distance formula, the distance between two points, or again, the length of the segment connecting those 2 points, is the square root of, well, a is the difference of our x coordinates, x2 minus x1 squared, plus b is just the difference in our y coordinates. So it's y2 minus y1 squared. So for these points up here, I had 2, 11, and 14, 6. The distance between those 2 points is going to equal, again, I'll label them 0.1 and 2. X2 is 0.2, the x-coordinate is 14, minus x1 is 0.1, the x-coordinate is 2. And of course, that difference will be squared. Plus y2 is 0.2, the y-coordinate is 6, minus y1 is 0.1, the y-coordinate is 11. That distance will be squared. So on our next step, we're going to do the subtraction. 14 minus 2 is 12. That's going to be squared in the next step. 6 minus 11 is negative 5. That'll be squared in the next step. Now you might be thinking we're getting a negative number here for a distance. We can't have a negative for a distance. But it doesn't matter because we're going to square it in our next step. So 12 squared is 144, plus negative 5 squared. Remember, be careful on your calculator. If you just type in negative 5 and hit x squared, it's going to try to tell you it's negative 25, and we know that's not true. A negative 5 squared is negative 5 times negative 5, and a negative times a negative is a positive. In fact, we know that any number squared has to be positive. Remember, on your calculator, when you square a negative, you have to put it in parentheses first. The negative 5 in parentheses, and then the squared outside the parentheses to get the positive 25. So negative 5 squared is positive 25. We add those together. 144 plus 125 is 169. And so our distance is the square root of 169, which is 13. So the distance between those 2 points is 13 units. Well, let's apply this one a couple of times. Let's take a point, negative 5, 2, and negative 10, 11, and see what we're going to get for a distance between them. So again, I'm going to label this point 1 and point 2. My distance formula, x2 minus x1 squared plus y2 minus y1 squared, square rooted. So x2, point 2, x coordinate is negative 10, minus x1, well, point 1, x coordinate is a negative 5. I screwed that up pretty bad, didn't I? Now we'll see what we get. For y2, point 2, y coordinate is 11, minus y1, point 1, y coordinate is 2. Now we're going to do our subtraction. Negative 10 minus a negative 5 is negative 10 plus a positive 5, which is negative 5. (11 minus 2 is 9. Now we have to square them. Negative 5 squared is 25. 9 squared is 81. We add those together. 25 plus 81 is 106. And we have to take the square root. Square root of 106. Oops, clear that out. Come on now. There we go. Square root of 106, 10.296. That's our length of that segment connecting those 2 points, or the distance between those 2 points, 10.296 units. Let's do one more. Let's say we've got negative 3, negative 5 to positive 9. Scratch that. I'm going to make that positive 13 and a positive 7. So now, find that distance between them. X, or label them points 1 and 2. X2 is the 13, minus X1 is the negative 3. So it's 13 minus negative 3 squared, plus Y2 is the 7, minus Y1 is the negative 5. So it's 7 minus negative 5 squared. Now, once you have this down, you could just punch this in the calculator. You could do the square root of, and then It puts a parentheses there. Most calculators put that first parentheses there. If it does not, you need to put it in. Then you need a second parentheses to do the first subtraction. 13 minus negative 3. Close the parentheses, x squared. Plus, parentheses, 7 minus negative 5. Close the parentheses, x squared. Then you close the parentheses one last time to close the parentheses for the square root. And it will spit out your answer of 20. That can be tricky to put in the calculator. I'll leave that up there for a second so you can see the entry. Or we can just work through it. 13 minus a negative 3 is 13 plus 3, which is 16 squared. Plus 7 minus a negative 5 is 7 plus a 5, which is 12 squared. $16 squared is 256. 12 squared is 144. I add those together, I get 400, and the square root of 400 is 20. So, yeah, that's the same number we had, just punching the formula into the calculator. So I'm going to have you try an example of this. 3, negative 9, and negative 5, 6. Find the distance between those 2 points. We'll go over it in just a minute. Let's take a look and see how you're doing here. So if I label the points 1 and 2, the distance is the square root of x2 is negative 5 minus x1 is 3, so it's negative 5 minus 3 squared. Y2 is 6 minus y1 is negative 9, So it's 6 minus negative 9 squared. So negative 5 plus or minus 3 is negative 5 plus a negative 3, which is negative 8 squared, plus 6 minus a negative 9 is 6 plus 9, which is 15 squared. 8 squared is 64, and 15, or negative 8 squared is still 64. 15 squared is 225. 64 plus 225 is 289, and the square root of 289 is 17. So the distance there is 17. So this is part of the worksheet. I realize I've already gone over the first hour. This is part of the worksheet that is out there for you to work on for today. The other part deals with relationships between lines on the graph. If I graph the equation y equals 2/3 x minus 1. So that means I start out here at negative 1. That's my first point. And from there I go up to run 3 to get to my second point. And my line goes through those points. Well, if I graph the equation y equals 2/3 x plus 3, that one starts at 1, 2, 3 above the origin. And from that first point, we go up 2 and run 1, 2, 3. And my line goes through those 2 points. What I notice about those 2 lines is that they are parallel. What about those equations makes them parallel? Well, we've mentioned this before. They have the same slope. Parallel lines have the same slope. So if we're given 2 equations, we can tell if their lines are parallel. Y equals 3/4 x plus 5, or 4y equals 3x plus 8. Well, the slope of this first line is 3/4. The second line, we need to do a little work to get the slope, because y is not by itself. We have to divide by 4. Well, we divide by 4, gets rid of the 4 on the left side, so we just have y. 3x divided by 4 is 3/4 x. Plus 8 divided by 4 is 2. That also has a slope of 3/4. So those 2 lines are parallel. We might have 5x minus 2y equals 8, and 4y equals 8 minus 10x. Sorry, 8 plus 10x. I have to solve these to find the slope. So up here, I'm going to subtract 5x from both sides. Get a negative 2y equals 8 minus 5x. Then I'm going to divide by the negative 2, giving me y equals 8 divided by negative 2 is a negative 4. Negative 5x divided by negative 2. Well, negative divided by negative is a positive. 5 divided by 2, I'm just write it as 5 over 2x. That line has a slope of 5 over 2, 5/2. For this one, all I have to do is divide by 4. Give me y equals, well, 8 divided by 4 is 2. 10x divided by 4 is just 10 over 4x. But 10 over 4 can be reduced to 5 over 2. That's the same slope, 5 halves. So those two lines are parallel. Now, more often than just trying to determine if two lines are parallel, which in construction is very important. We do it on trusses, floor plans, and all sorts of things if we're graphing between 2 points. We can use this on a grid, by the way. If I give you a point here, 6, 2, and another point up here, let's call it 18, 11. And I know a line connects those two. Well, if I have another line over here, let's call this point 2, 5. And another point up here, let's call this one well, let's call it 6, 8. That point down a little bit. If I want to know if those lines are parallel, I just have to find their slope. The slope for this line, again, remember, it is, if I call it point 1 and 2, it would be y2, 11 minus 2, over x2 is 18 minus x1 of 6. So that's 9 over 12, which reduces to 3/4. Over here, I call them points 1 and 2. I have y2 is 8 minus y1 of 5 over x2 of 6 minus x1 of 2. That's 3 over 4. It is the same slope. So those two lines are parallel. The other thing we need to be able to do is, if given a line and a point that another line goes through, we need to be able to construct the equation through that line parallel to the original line. Find the equation of a line parallel to y equals 3/2 x minus 5, and through the point 6, 1. Let's do, 6, 1. What the heck? So the only piece of information we need out of this equation is the slope. The slope is 3 over 2. That means the slope of a line parallel will also be 3 over 2. So we know the beginnings of our equation here is y equals 3 over 2 times x. We do not know what the y-intercept is, b, so I put just plus b there. This should look very similar to something we did at the end of Unit 3. I plug in my point, 6, 1. So y is 1, x is 6, and now I can solve for b. So 3/2 times 6 is 9, and I subtract 9 to get -8 equals b. So that means my equation here is y equals 3/2 x, and b is -8, so -8. There's the equation of that line parallel to the original equation through that given point. I'm not going to write up the whole thing. Find the equation of the line parallel to y equals -1/3 x plus 7, and through the point 9, negative 3. So we know from this equation here, remember the only piece of information we need out of there is the slope. That's telling us the slope of that equation, if that line is negative 1/3. So the slope of a parallel is also negative 1/3. So that's what we need for this equation. We start out as y equals negative 1/3 times x plus whatever b is. We use our point then here, find b. Negative 3 goes in for y. Negative 1/3 times 9 goes in for x, and we're solving for b. Negative 1/3 times 9 is negative 1/3. And we solve by adding 3 to get rid of the negative 1/3. You get 0 equals b. So b equals 0, which means our equation is just y equals negative 1/3 x. Plus 0 doesn't have to go in, so just y equals negative 1/3 x. I want you to try one in your notes. So find the equation of a line parallel to y equals 3/4 x plus 1 and through the point 8, 2. I'll give you a couple minutes and we'll go over that one. Let's take a look here. So we know that from this equation, all we need is that the slope equals 3/4. That tells us the slope of the parallel is also 3/4. So our equation starts out y equals 3/4 x plus whatever b is going to become. We plug in that point 8, 2, so 2 goes in for y. 8 goes in for x. 3/4 times 8 is 6. And then we subtract 6 from both sides. You get negative 4 equals b. So if b equals negative 4, that means our equation is y equals 3/4 x minus 4. That's our equation. Perpendicular lines on the graph. If I graph y equals 1/4 x minus or plus 1, that starts at a positive 1 here, and from there it goes up 1 over 4 to get our second point. Our line goes through those points. Try that a little bit better. There we go. If I want to graph a line perpendicular to that, let's just go through this point here. Perpendicular means that this has to make a right angle, 90 degrees. Well, we have this slope triangle here that is 1 by 4. And we know that in any right triangle, the two angles that are not the right angle, in other words, this angle here and this angle here, have to add up to 90 degrees. Because the total, the angle sum of a triangle, is 180. The right angle is 90, so the other two must make up the other 90. So this angle and this angle combine to make 90 degrees. So if I draw that triangle again here, only this time with the 1 down here and the 4 up here, and that's my right angle, these two angles have to combine to make 90 degrees. So that slope, the rise and the run, change places. In other words, it's reciprocal. But also, this one had a positive slope, this one has to have a negative slope. That's called opposites. So for the perpendiculars, have opposite reciprocal slopes. So this line here would have a slope of a negative 4 over 1 instead of a positive 1/4. So again, we could look at two lines and we could determine, or two segments I could say, and determine from their endpoints if they're perpendicular. Let's say that this one here goes from negative 5,3 to 10,12. And this one here goes from 2,15 to what do I put in there? 6,3. Now we have, actually that's not going to work, is it? Let me try that again. This will be, we'll call this 0 and 9, 11. I know the points don't match up, but anyway, for this equation here, for these 2 points here, as not an equation, for that segment, the slope, if I call this point 1 and point 2, the slope is 12 minus 3 over 10 minus a negative 5. 12 minus 3 is 9. 10 minus a negative 5 is plus a positive 5 is 15. And that reduces both 9 and 5 divided by 3, or 9 and 15 divided by 3, give me 3 over 5. This one here if I call this point 1 and this point 2, I have y2 is 0 minus y1 of 15 over x2 is 11 minus x1 of 2. That gives me 0 minus 15 is negative 15. 11 minus 2 is 9. Both of those numbers divide by 3. 15 divided by 3 is 5. 9 divided by 3 is 3. And I have the negative which goes in front. So 3/5 is the reciprocal of 5 over 3. Also, they're opposites. 3/5 is positive. Negative 5/3 is negative. So those are perpendicular. Again, back to what we were doing before with the parallel lines. We might be asked to find the equation of a line perpendicular to y equals 2/3 x plus 1 and through the point 4, 3. So this time, all we need from this equation is still just the slope of 2/3. The difference is it's perpendicular. So we know the slope of the perpendicular is going to be the opposite reciprocal. This is positive, so the perpendicular is going to be negative. And the reciprocal 2 over 3 becomes 3 over 2. So negative 3 over 2 is the slope of our perpendicular. So the equation for our line here starts out as y equals negative 3 over 2x plus whatever our y-intercept turns out to become. We plug in the point that's going through, put 3 in for y, 4 in for x. We multiply. Negative 3/2 times 4 is negative 6. And we add 6 to get rid of the negative 6. 9 equals b. So the equation y equals negative 3/2 x plus 9 is our y-intercept. Well, I wanted to make sure I gave you plenty of work time here. We went through the break, so I owe you 10 minutes for that. So we only have 21 minutes, about 20 minutes left actually now. So I'm going to give you that 20 minutes. To get started if you want, there's a worksheet in Blackboard for today. For December 14th. Actually, there's a couple of them. There's one on the formulas and then one on the parallel and perpendicular lines. So that is your homework for today. Remember, the quiz for 3 variable systems from last week, Thursday. I mean, it was supposed to be due Friday, but I had given you guys permission to turn it in today. Make sure you get that turned in today if you have not turned it in yet. Anybody have any questions? Okay, well, I'll give you the last 20 minutes here to work. I'll be on the network to answer your questions if you need anything.